and resend the link to Jayashree ma'am.
Yes, ma'am, I'll send. We're just going live, though. Just close your this video. I'll just send the link.
She has
I'm
joined, Ruby.
myself. Me.
Hello, Megha. You don't need to send it.
Yes,
She's
ma'am.
joined now. Okay, she's joined. Okay, fine.
And
Okay, resend the link to Jayashree ma'am.
Right now, I'm in the train.
I'll send. We're just going live, though. Just close your this video. I'll just send the link.
She has joined, Ruby.
Okay.
Hello, Megha.
Okay, all videos and mics off now. Directly at 5 o'clock.
Hello, good evening, friends. A warm welcome on behalf of Indian Dietetic Association Mumbai chapter to this webinar on micronutrient deficiency in intergenerational life cycle. Friends, we have organized this webinar in two parts. Today, we have the keynote address by none other than the eminent Professor Dr. Yagnik sir, and which will be followed by a panel discussion on 28th, which will be moderated and by Ms. Neeti, and we have 6 eminent panelists for that program. This webinar has been organized in collaboration with HATSA, which is Health, Food and Dietary Supplements Association. Friends, micronutrient deficiency is also referred to as hidden hunger that affects the health of many people. Micronutrients, though, are required in small amounts, but still they affect the normal growth and development of the human body if they are not provided in the diet. Micronutrient malnutrition is the term which we use to refer to the diseases which are caused by this deficiency of these. Well, not taking much time, I would just like to welcome all of you. We have people from HATSA. We have, I'm sure Dr. Kulkarni is here, who is the honorary secretary and board member of HATSA, and we have many HATSA members who've joined in today. We have a lot of senior people from IDA today who are going to be part with us for this webinar. Thank you all our IDA colleagues, friends, seniors. Friends, I also take this opportunity to welcome our national president, Madan ma'am, who has always been the guiding force for us and has been telling us what is right for us. I request ma'am to give her opening remarks for this webinar. Over to you, ma'am. Thank you.
A very good evening to one and all. Warm greetings from the Indian Dietetic Association, the large fraternity of 20,000 life members in 25 chapters across India. I'm so delighted to be a part of yet again very prestigious event of IDA Mumbai chapter, which I think every delegate who's here, the life member of IDA, I think this event is not only for the IDA Mumbai chapter delegates because we are virtual. So this is pan-India, and I'm sure not only pan-India, it will be probably global as well, because there are many people who would be looking forward to this talk by none other than eminent and legendary figure who's a role model for all of us, and Professor Dr. Chitranjan S. Yagnik. I'm extremely happy today that IDA Mumbai chapter is collaborating with HATSA, the Health, Food and Dietary Supplement Association. I think HATSA has been our partner for many, many events, even in the past. And together, I think we want to reach many milestones. And congratulations, Zamrud, for sustaining this collaboration. And I think these 2 consecutive events are in collaboration with HATSA. So I welcome all the office bearers of HATSA, and I think Mr. Kulkarni and Mr. Weber will be joining, I think, tomorrow. But all the delegates from HATSA, you're welcome for the session. I must reiterate that the theme for the National Nutrition Month has been malnutrition, whether we are talking about the pediatric malnutrition or whether we are talking about malnutrition through the life cycle. And the endeavor is to arrest this malnutrition at an early stage. And I think that is where the efforts of we as nutritionists have to reach out to each and every stakeholder. And that's where our reach, our strength needs to be maximized and utilized. So IDEA Mumbai chapter has done a number of remarkable programs in the past, addressing severe acute malnutrition, addressing micronutrient malnutrition through kitchen gardens or Paude Se Poshan. That's another theme which is being emphasized in this nutrition month. So today we are delighted to have with us Professor Yagnik, and we are really looking forward to this deliberation because it will be a learning experience for all of us. And I congratulate the entire team, and I welcome all the members, delegates from IDA across India and member delegates from HADSA for this event. Thank you very much for inviting me.
Good evening, everyone. Thank you so much, ma'am, for addressing this August gathering. We have more than 150 delegates on the Zoom now, and virtually many more on the YouTube. Everybody's excited to listen to the scientific deliberations ahead. As you all are aware that this is a joint program between IDA Mumbai chapter and the Health, Foods and Dietary Supplements Association, it is indeed my honor to introduce to all of you the Honorable Secretary and Board Member of HADSA, Dr. Vaibhav Kulkarni. Sir, I request you to kindly unmute yourself and welcome the audiences and also give a slight introduction background of the association for those who are the members of Indian Dietetic Association. Dr. Vaibhav Kulkarni, over to you.
Okay, thanks, Ruby. I have a little bit of problem with the internet, but still, I'll just try to talk on the part till the time our internet is good. So first of all, I welcome all the delegates from IDA and from HADSA to this wonderful program that we are doing on a very important topic, and that is micronutrient deficiencies. It's so important in this point of the world, and the topic is very useful when it comes to this nutrition month that we're trying to celebrate. So let me give you a little bit of background of HADSA, because most of the people are not aware, but most of them are aware. For the ones who are not aware, let me tell you, HADSA was established in the year 2002 with only 4 patron members. From there till now, we are somewhere around closer to 180 members, and it was not a straightforward journey. It was like tumultuous journey. And if you see by the name itself, HADSA, it's more of a we are talking about in the year 2002. We were talking about dietary supplements, health supplements category, and all that, which was, I think, not very well known at all. People were not able to distinguish at that point in time which was the normal food and what is the supplements kind of. Everything was a supplement or everything was a food for people. Even that time, people were not very clear whether this is food or whether this is drug. So in that entire stuff which went through up till the year 2016, when a clear-cut regulations came into play by the Food Authority, and the Food Authority took control of the dietary supplement regulations. And that's where now we actually sit in the food part of the regulation. So HADSA happened to be formed in 2002 with 4 patrons, and then we up till now we have got corporate membership up till 180 corporates and individual members around. So what was the mission of HADSA? The mission of HADSA is to develop, help, and guide nutraceutical and food industry, academia, and other organizations with government initiatives. Also, HADSA was formed to promote science through healthy, safe, and quality products that increases the market share of the Indian dietary supplements in the global market, as well as bringing in the global players and giving access to our market and to our consumers. What are the objectives of HADSA? So HADSA has got 5 objectives. One is knowledge and education, and knowledge is like this is what we are trying to do today. And in our, this is our one of the objectives, where we want to dissipate our knowledge. This is kind of an industry experts and the association amalgamation, where we can dissipate the knowledge to the members of various associations, as well as probably going to the one step further, dissipating the knowledge to the hello, are you able to hear me?
Yes, sir.
Hello.
Yes, Dr. Kulkarni, yes.
Okay, thank you. So dissipating the knowledge not just to the members, but to the last mile person, and that last mile person is for me is the student who are studying at this point in time in colleges. So that also is one thing that we are kept in that the stuff in our mind. There's a social responsibility to it. We also provide industry services wherever required, advisory support to the industry, because in nutraceutical is a niche topic and niche subject at this point in time, and anywhere anybody wants help, HATSA is always willing to help them, and we have been helping them. Also, the last part, but not the least here on the mission front, is the government representations, where there are a lot of advisories that government put forth for the from the industry point of view. And we at HATSA, what we do is we really look at through our legal battery of lawyers within our scope in HATSA, as well as the regulatory folks. We look at those advisories and regulations, and wherein possible, take the inputs from our members, and that same inputs then we put forth in front of the government to see to it that we shape the regulation. We do the advocacy to shape the regulation so that it is little bit, it is not harsh on the companies, and there is a scientific logic behind of what all things that government does. So where do we fit in? Where do we fit in all the scientific and business communities who develops and helps the industry? It also guides the government initiatives and the academia. Have a social role, as I said, on providing scientific and quality products, services to support consumer and industry, providing knowledge and education to member organizations and all other stakeholders who are a part of HATSA. Also, advisory role, as I said. So these in all what we do and what is HATSA made up of. I would encourage all the IDA members. I think we have done earlier that drive, but I would also urge my secretariat, Alina, and the IDA secretariat, Ruby, and the team to really look at increasing the membership here, because this membership will definitely increase our partnership, and at the same time it will also provide a lot of expert opinions, expert views from the HATSA point of view and from the HATSA kitty, because HATSA is also a corporate member to IATSA, which is an international dietary association. Having said that, now I'm going to stop, because this entire stage now belongs to Dr. Yagnik, and I would say this is what the introduction for the HATSA is. Hope you had a good session here, and over to Dr. Yagnik now.
Thank you, Dr. Vaibhav Kulkarni. I take this opportunity to introduce the topic before we invite our keynote speaker today. Well, let me begin by defining what is micronutrient deficiency. We know that micronutrient deficiencies is defined as the lack of essential vitamins and minerals required in small amounts by the body for proper growth and development. However, let us also understand that nutrient availability is far different from the actual food consumption. Anybody eating food does not mean gets all the micronutrients in their diet. Let us understand what are the figures. The WHO estimates that more than 2 billion people suffer from this micronutrient deficiency globally. And as per the 2018 Global Nutrition Report, the burden of malnutrition across the world remains unacceptably high, and the progress is unacceptably slow. Malnutrition is responsible for more ill health than any other cause. As of today, also we see a lot of people who are losing their lives due to COVID are also either malnourished or one of the reasons behind that. Children under 5 years of age have multiple burdens. 150.8 million children are stunted globally, 50.5 million are wasted, and 38.3 million are overweight. Isn't that a very big and alarming number? Especially with women. Women have a higher burden when it comes to malnutrition. We know that 1/3 of all women of the reproductive age have anemia, and women have a higher prevalence of obesity as well. However, at the other end, millions and millions of women are still overweight. We know that the long-term consequences of malnutrition deficiencies are health deleterious to the health. So it is a very big concern. So perhaps the greatest concern is over generations and intergenerational consequences are only where we begin. Now, to understand the whole cycle, we have hence organized this lecture where Dr. Chittaranjan S. Yagnik will take us over the scientific deliberation. Not taking any more time further, I would request Dr. Jagmeet Madan ma'am to introduce our eminent speaker for this evening today. Over to you, Madan ma'am.
A very good evening once again. It is my indeed proud privilege to introduce the legendary Professor Dr. Chittaranjan S. Yagnik. I don't think so there's anyone in the nutrition fraternity who can afford to miss the deliberation or the keynote address given by Dr. Yagnik. Dr. Yagnik is the Director, Diabetes Unit, KEM Hospital, Pune. He's a renowned diabetologist and a researcher. He initiated a pioneering randomized controlled trial to improve micronutrient status of adolescents to reduce susceptibility of diabetes in the offspring. He is well known for his description of the thin fat Indian, the phenotype, which we all, the moment we talk about thin fat Indian phenotype, we only connect to Dr. Yagnik. He's created a unique biobank dating back to samples collected from 1987, which is exemplary, spanning many cohorts and a life course serial collection of blood, urine, stool, and buccal smears in 3 generations for the historical Pune maternal nutrition study. He's a founder, member, and president of SNEHA India, that's the Society for Natal Effects on Health in Adults. He's a founder, member, and trustee of International DOHa Society, that's Developmental Origins of Health and Disease. He has many, many accolades to his credits, and some of the awards which he has got in the recent past, I must share with all the youngsters who are listening to us so that they are inspired by such a legendary figure. Dr. Yagnik has been awarded Helmut Mehnat Award, IDF, International Diabetes Federation 2009, David Barker Medal of the International DOHa Society 2011, Outstanding Investigator Award, WIDF 2016, 41st Gopalan Oration Award, Nutrition Society of India 1718, and March of Dimes Agnes Higgins Award 2019. Dr. Yagnik, we are blessed today that in this Nutrition Month, Ocean Ma, we got the opportunity to invite you to IDA Mumbai chapter and hear your keynote address. Over to Dr. Yagnik. He's going to be speaking on micronutrient deficiency in intergeneration life cycle. Welcome, Dr. Yagnik. With folded hands, we welcome you. Dr. Yagnik, we cannot hear you.
Can you hear me now?
Yes, we can hear you.
Yeah, that's right. Okay, sorry.
And if you can go on to the slideshow, Dr. Yagnik.
Yeah. Are you able to see the slides?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. So thank you, Dr. Madan. Thank you for inviting me for this very interesting session. Thank you, IDA. Thank you, Hatsa, for remembering me and for giving me the topic, which is really topic after my heart. So we are going to look at intergenerational micronutrient deficiency of a particular vitamin or two vitamins like B12 and folate, and how diet, genes, and environment act together in this interaction between the generations to improve not only the nutrition as we understand it classically, but also the risk of non-communicable disease. And in this case, that of diabetes and adiposity. So we'll see this as we go along. I'll start by saying that my unit of diabetes at the KEM hospital, Pune, is the only diabetes unit in the world where the logo is mother and baby. And you can imagine this has been the focus of our research since 1985 when I joined the KEM hospital. The other logo you can see here is the modern Ganesh. And modern Ganesh, instead of traveling on the back of the mouse, which you can see here, that mouse is looking at Ganesh and is very cross that Ganesh has forgotten him at the cost of clicking these many mice of the computer, and therefore is running away from this mouse. So this intrauterine undernutrition and then a rapid transition which produces obesity and other disorders have been the focus of our research over last many years. And we have a number of collaborators, as you can see here, both national and international. I'm just going to start by telling you that B12 is the only nutrient for which 5 different Nobel Prizes were won. So it's a very remarkable nutrient. No other nutrient has such a distinction. And what does B12 do in human beings? It acts as a cofactor for 2 enzymes. One is called methionine synthase, where B12 and folate together activate that enzyme to convert homocysteine to methionine. And methionine in turn regulates the synthesis of what we call SAM. Now, SAM is a term which is today used for severe acute malnutrition. Here, we use it for S-adenosylmethionine. So S-adenosylmethionine is the universal methyl group donor in the cell. And when it donates the methyl group, it gets converted into SAH, S-A-H, which is S-adenosyl homocysteine. And this methyl group is then free to interact with a host of reception sort of molecules or receptors for methyl group, which include various things like proteins, lipids, and importantly, DNA molecule. So the methyl group donor actually is important in a series of reactions which are involved with DNA synthesis, DNA repair, DNA regeneration, and importantly, DNA methylation, which is a process which regulates gene expression. And that is what we call epigenetics. The other enzyme which B12 regulates is a mutase enzyme. And that mutase converts methyl malonyl CoA to succinyl CoA. And you will remember from your training days, succinyl CoA is an intermediate in the Krebs cycle or the TCA energy cycle. This happens in mitochondria. the other reaction happens in the cytoplasm. So B12 regulates these two important processes and therefore has multitude of effects, not all of which are even understood. So folate and vitamin B12, as I said, are two related vitamins. Vitamin B12 and folate is also called F9, so vitamin 9. Folate, as we all know, is of vegetable origin. Vitamin B12 can be made only by microbes, and it is consumed by humans through the animal source food, which the animals sort of deposit in their tissues by consuming the microbes. So vegetarian and non-vegetarian sources. Therefore, deficiency of folate is more common in non-vegetarians, while deficiency of B12 is common in vegetarians. Interestingly, B12 deficiency is somehow the more common in the higher socioeconomic group, probably because they have a better hygiene and they can afford to eat more non-vegetarian or animal origin food, and hygiene is related to the microbial contamination. So if you remove the microbes from your microenvironment and you are also vegetarian, then your chances of becoming B12 deficient are quite high. B12 is little affected by cooking. Folate is affected quite substantially by cooking. B12 is required in the tune of 2 to 3 micrograms per day. Folate about 50 to 600 micrograms per day. Absorption of folate is good. Absorption of B12 is very regulated, as we will see a little later. Folate deficiency causes high levels of homocysteine, while B12 deficiency causes high levels of homocysteine as well as methyl malonic acid, and MMA is a specific indicator of B12 deficiency. It's not measured routinely in all the laboratories. It's an expensive measurement, so we do it in the research. And in clinical practice, we use either folic acid or folinic acid in the various preparations, while B12 is used either as cyanocobalamin, methylcobalamin, and occasionally as adenocobalamin. So in my department, since 1985, we have a series of studies which we have done and found out many interesting things. And I'm going to tell you this story of these sort of research projects, the different sort of grants, the different sort of investigations we have done. So to start with, vitamin B12 absorption is an important consideration. And why is it important? Because when I started my research in 1980s in vitamin B12, the textbooks mostly mentioned B12 deficiency as related to pernicious anemia. And it is a genetic autoimmune condition where you lack the intrinsic factor which is secreted by the gastric parietal cells. And intrinsic factor is necessary for absorption of B12. So if you don't have intrinsic factor, you don't absorb B12 and you become B12 deficient. What we see commonly in India is a nutrient deficiency. It's low dietary intake of B12, especially in vegetarians and vegans, and sometimes in low socioeconomic group people if they can't afford the non-vegetarian food. Associated conditions of pernicious anemia are therefore related to autoimmune disorders, while B12 deficiency nutritional is associated with iron, folate, and other deficiencies. The nutritional deficiency is usually less severe than pernicious anemia, and therefore small oral doses might be effective, though currently there is a grossly inappropriate use of very high doses of methylcobalamin in clinical practice. I'm sure you have learned about B12 absorption. It's a very complicated issue where B12 first combines with proteins in the food that enters your mouth and the gastrointestinal system. Then it is carried after the gastric acid sort of separation with the salivary R factor, then is digested in the pancreas, then it combines with intrinsic factor, is carried through the small intestine, then this complex of intrinsic factor and B12 combines with the receptors in the terminal ileum, gets through the intestinal wall, and is carried by different proteins in the blood to different tissues. This is one of the most complicated absorption mechanisms, and we wonder, on one hand, bacteria make it, so it is present in the evolution for millions of years, while humans have an extremely regulated intake mechanism, probably because, as someone said, the cargo is too precious or might be dangerous in large doses. So I'm going to tell you about B12 in DOHa phenomenon. And this is a new sub-branch of medicine after David Barker published his paper that low birth weight is a risk factor for future diabetes, blood pressure, heart disease, number of neurological, psychiatric conditions, and a whole lot of things. And the idea is that maternal influences of nutrition on the baby influence its growth and differentiation through effects on the epigenetic mechanisms. And these epigenetic marks, or at least some of them, are responsible for fetal development and differentiation. Some of them remain with you for the rest of the life and in turn affect your birth phenotype, like your birth weight, length, head circumference, etc. Then there is subsequent environmental exposure during postnatal growth. And then you start looking at risk factors for morbidity or mortality related to what we call intrauterine programming. And that is the basic sort of vision of this international DOHa society. And all this is then converted into some very basic ideas in the field of development and differentiation. And what is this idea? Plasticity is a term which is used very frequently in developmental biology. And what it means is a freedom of growth and development, provided you have good genes and you have adequate environment. So if you have good genetics and you have a plentiful of supply in the intrauterine life, then your growth is plastic and it will go along the best possible pathways. If you are genetically compromised in some way, or if your environment in the uterus is not good, that means either there is nutritional deficiency or maternal metabolic disease like diabetes, or pollutants getting into mother and reaching to the baby, maternal stress, a number of things. These restrict the plasticity of the growth and development, and that is called programming. And if this programming happens in a bad way, it predisposes you to future disease. If programming happens in a good way, it predisposes you to health. And that is why the term DOHa, that is developmental origins of health and disease. Naturally, because the growth is very orchestrated in utero, there are windows of vulnerability. That means neural tube defect or neural tube develops in first 3 weeks of life. So if there is a problem of folate or B12 deficiency at that time, you get neural tube defects. Cardiac development occurs around same time, so it might affect cardiac development. Pancreatic development occurs a little later, it might affect pancreatic development. Every organ system is likely to be affected if the intrauterine environment and nutrition is not good. So this is the vulnerability and the window of vulnerability. On the other hand, we can convert these into windows of opportunity. So if you want to do something good in a population which has a lot of B12 and folate deficiency, if we concentrate on the health of the adolescents or a woman who's going to become pregnant, we have an opportunity to overcome the bad effect of programming and convert it into a good programming. And the period which is most important for this is pre and peri-conceptional period. And this is the time when the woman doesn't even know she is pregnant. So this is first few phases of development up to what we call gastrulation. And therefore it is important to improve the nutrition and health of the young girls before they become pregnant. And that, I think, is one of the most important messages you will take home today. And as I said, the mechanisms involved in this programming include genetics and epigenetics. So we set up this study called Pune Maternal Nutrition Study after I met David Barker in 1991 and established in a small study which we did in KEM Hospital, Pune, that low birth weight was associated with higher insulin resistance in the children who were born in KEM Hospital. So once I was convinced that what David Barker was saying was applying to the Indian situation, we decided we needed to study the determinants of fetal growth in Indians, because you know India is the world's capital of low birth weight babies. 1 in 4 babies are born low birth weight even today in many parts of India, though not all parts of India. So India is the world's capital. And secondly, we wanted to establish life course evolution of phenotypes after a baby was programmed in utero through our studies. And I'll tell you what we did. So we went to 6 villages near Pune and documented all women who were married but not pregnant. And there were more than 2,500 of them. We followed them every month for their menstrual dates, and we did their hemoglobin measurements. We then studied intensively 800 plus women who became pregnant during our study period, that's 1993 to 96. We studied their nutrition, their physical activity, their metabolism, glucose tolerance test. We studied fathers, and we studied fetal growth by ultrasound. When the babies were born, we measured their anthropometry in great detail. So not only weight, but also length, head circumference, chest circumference, abdominal circumference, mid-upper arm circumference, skin folds, everything. Because we wanted to study their body composition also. Then after birth, every 6 months, we have done their growth measurements for 18 years. That means till they became young adults. And every 6 years, we study the child and the parents for a detailed evaluation of their nutrition, their physical activity, body size, body composition, cardiometabolic risk factors, and other things. And recently, we had to stop our 24-year follow-up because of the COVID after we had studied 250 out of possible 700. And you will see we have very good follow-up rates of more than 95%. And we have a biobank, as Dr. Madan told you, collected right from the beginning of pregnancy till each further follow-up. So we have lots of samples with us. So the average mother in the Pune maternal nutrition study started her pregnancy at a weight of 42 kg and a body mass index of 18.1 kg per meter square. And the babies which were born were on average 2.7 kg. And 50 to 70% of these babies were SGA, that is small for gestational age, depending on which criteria you use. If we use intergrowth criteria, now we know it applies to about 50% of babies born in our cohort. The mothers were predominantly vegetarian. Their intake of energy and protein was only about 75% of the recommended ICMR guidelines. Carbohydrates formed large part of the energy intake, and they had a lower intakes of green leafy vegetables, milk and fruits, 3 food items which are very rich in micronutrients. And they did lot of physical activity, as you can see in these slides. These women are carrying either water on their head, or they would be working in the farm, or they will be cooking for the family. And there was no increase in the intake or reduction in the physical activity with increasing gestation. So that was a very interesting finding. And Dr. Shobha Rao was responsible for all these nutritional and physical activity measurements. For the criteria which we used in 1993, the WHO 1985 criteria for GDM told us that less than 1% of these women had gestational diabetes at that time by the WHO 1985 criteria. So what was the association of maternal nutrition with fetal growth, and what was the body composition of the fetus? So here I have shown a baby born in Pune, and there is a baby born in Southampton, where David Barker and Caroline Fall, our 2 major collaborators, worked. So the baby, Indian baby, was 700 to 800 grams lighter, 2.7 kg as opposed to 3.5 kg. But as I told you, we hadn't measured only weight, we measured number of other things. So that told us that though this baby was small and thin, its subscapular skin fold thickness was actually as much or even larger than the English babies. And that is how the term thin fat Indian baby came. So babies were thin by their ponderal index or body mass index, but they had more fat when you measured it. And because people really didn't believe us, we went on to do a MRI, whole body MRI of 30 babies born in Pune and 30 babies born in London. And what did it show? It showed that even on MRI, the fat in the intra-abdominal and the subcutaneous compartment of the abdomen was higher in the Indian babies, despite they being 700 to 800 grams lighter. We then found that micronutrient-rich foods like GLV, green leafy vegetables, milk, and fruits had a strong association with birth weight. So higher the consumption frequency, larger the birth weight of the child. Maternal red cell folate concentrations were also strongly related with the fetal size or neonatal size. And then we found that homocysteine, which I told you is one of the important metabolites in the 1-carbon cycle, and homocysteine is increased if there is folate and or B12 deficiency. So high maternal homocysteine concentrations predicted SGA, that is small for gestational age babies. So that if the mother was in the highest quintile, her baby was 3 times more likely to be SGA than the lowest quintile. And where did this high homocysteine come from? 2 out of 3 mothers were B12 deficient. Folate deficiency practically absent because they were all eating vegetarian food made in their farms, etc., and also eating many small fruits like borer, so zizapus, or peru, and other fruits which are grown locally. Homocysteine was high in 1/3 of the mothers, and MMA, which I told you is a specific indicator of B12 deficiency, was high in 90%. So what this slide shows you is that micronutrient containing foods had a positive effect on fetal growth. Circulating nutrients of folate had a positive role on fetal growth, but high homocysteine had a negative effect. So we related this to vegetarian, like say, habits of this population. And vegetarianism in India is different than the Western world. In Western world, it's a new idea. They were predominantly non-vegetarian for many, many generations. While we are multi-generationally vegetarian since days of Samrat Ashok, who was the first proponent of ahimsa and vegetarianism. 3 religions strongly support vegetarianism. And as I told you, higher education, higher income, and better hygiene, that means especially middle class and higher socioeconomic class people, have a higher risk of B12 deficiency, especially if they are vegetarian. Folate, on the other hand, if there is high intake of vegetarian foods, chances of folate deficiency are reduced. So higher socioeconomic status means you will have a good folate status. There is National Anemia Prophylaxis Program, which gives IFA tablets to adolescents and pregnant women. So that also provides folic acid. And obstetricians use high-dose folic acid tablets, what we call Folvite, to reduce the risk of neural tube defects. We won't go into that practice just now. It's an interesting thing in itself. But the neural tube is prevented by 400 micrograms of folate if given daily from before conception. So at least a few months before conception and during first trimester. Majority of our women do not come to see doctor much after the neural tube is closed. But obstetricians forget that and give large dose folic acid tablets. And what's the tablet strength? 5 milligram. 5 milligram is 5,000 micrograms. As I told you, daily requirement is 400 micrograms to prevent neural tube defect. So each tablet is at least 12 times higher folate dose than what is needed. And importance of this, you will see a little later. So we followed up these children, and I'm showing you results at 6 years, 12 years, 18 years for different outcomes. So what we found is that maternal B12 and folate levels in pregnancy were related to diabetes risk factors in the baby at 6 years of age. So if mother had high red cell folate, her baby was likely to become even more adipose. Originally, the babies were thin fat. But if mother had high folate, probably through supplements or through dietary intake, then that baby was more likely to be adipose. And if the mother had low B12 and high folate, This combination was related to higher HOMA-R, which is a measure for insulin resistance in the baby. So two risk factors for diabetes, adiposity and insulin resistance, were higher in the baby if mother had higher folate but lower B12 status. And our findings have been replicated in Nepal. Now they have also been replicated in Spain, and many other people are trying to replicate it because it seems to be a universal phenomenon. Maternal folate intake was still associated with adiposity at 18 years of age when we measured it by MRI. Now, what we found was, in addition, low maternal vitamin D was also a regulator of high adiposity in the baby. So now we are adding a third micronutrient. So low vitamin D and high folate increase the adiposity at 18 years. Low B12 and high folate increase the risk of diabetes risk factors in childhood. And additionally, we found that low B12 or low folate both affected neurocognitive development of the child. And currently, I have a psychiatrist, Dr. Rishikesh Bere, who is my fellow. He is looking in detail at the MRI of the children born in Pune maternal nutrition study. And he has already shown that low B12 of the mother, low B12 status of mother in pregnancy has affected development of certain areas of brain, and we are looking at its significance. So we have collaborators in Mysore, Dr. Krishna Veni and Dr. Caroline Fall also set up this study called Mysore Parthenon study. And what we find there is that low B12, that's B12 deficiency, is associated with higher BMI in the mother, so obesity. Low B12 was associated with higher risk of gestational diabetes. And when these gestational diabetic women were followed up 5 years later, then B12 deficiency predicted higher rates of permanent diabetes. In other words, low B12 status in the mother was associated with glucose intolerance, not only in pregnancy, but also subsequently. And the matters were made worse if folate levels were high. We have also done studies of neural tube defects in India, in 4 centers in India. This is one of the largest neural tube studies in the world, studying about 350 neural tube defects. And what we found there was, it was not really folate, but it was B12 deficiency, which had increased the risk of neural tube defects. This may be because most of these women were already taking IDA, that is IFA, that is iron folic acid tablets, or their obstetricians had given them, but B12 was not being given, and that was a risk factor for their neural tube defects. We also found much more pregnancy loss with B12 deficiency, growth restriction in the baby, and altered physiology and adult pathology, as I described to you in the previous slides. So this is what we called nutrition-mediated teratogenesis. And this is an idea. Teratogenesis is usually applied to only birth defects, like neural tube defects. But we are saying pregnancy loss, then growth restriction, altered response or altered susceptibility to diabetes and obesity are all imprinted intrauterine, and therefore we are calling it as a teratogenesis. And this is possible for the B12 and folate to do because, as I said, 1-carbon metabolism affects different aspects of metabolism. On one hand, it affects DNA synthesis, repair, Methylation, which I told you is the epigenetic story, genomic stability, and protein synthesis, which is of course very important for growth. Those of you remember your molecular biology, the initiator codon AUG codes for methionine. And as I told you, methionine is demethylated homocysteine. So the folate B12, by regulating conversion of homocysteine to methionine, allow good protein synthesis and therefore are important in deposition of lean mass, and thin fat story is based around all these phenomena. And we have done further research to show that B12 supplementation can epigenetically affect different genes, including genes for type 2 diabetes. We have also done GIVA study, which is genome-wide association study, to find out associations of B12 deficiency. We are also active with Dr. Yogesh Shauche in Pune, NCCS, for studying microbiome aspects of these things, and these studies are in progress. So I'm going to tell you now something quite interesting. How did serial B12 measurements in the children and the parents in the Pune maternal nutrition study tell us something very interesting. So this graph shows you serial B12 concentrations in the children born in Pune maternal nutrition study at 6 years, 12 years, and 18 years, 17 years of age. And as you can see, there is a progressive fall in B12 concentrations, so that at 17 years, 60% of the children are deficient. If you look at their homocysteine concentrations, at 17 years, 88% have hyperhomocysteinemia. On the other hand, folate remained fairly flat during this follow-up. So this is a very interesting finding, that B12 deficiency progressively worsens with the increasing age through childhood and adolescence. And what might be the reasons for this? One thing is, of course, genes. And the genetic study which we have done with Dr. Chandak in CCMB, Hyderabad, actually gave us many SNPs which are associated with B12. And they are all associated with different stages of absorption and transport, which I showed you in the first few slides. What is interesting is that if you have a gene risk score, then that determines your B12 concentration. So here you can see 6-year B12 concentrations are related to your gene risk score for B12. But as the age increases, these 4 groups, which are quartiles of gene risk score, are very faithfully following the course of downhill. In other words, those who have a good gene risk score were high at 6 years, high at 12 years, and high at 18 years. But all of them have fallen. And this is a classic example of gene-environment interaction during life course. That means so many things have happened subsequently that B12 has fallen. And what might be these? So we showed that maternal B12 concentrations are strong risk factors for cord blood vitamin B12, also for folate and homocysteine, but we will concentrate on B12. And cord concentrations of B12 are always higher than the maternal concentrations, because placenta actively transports B12 to the baby. It also actively transports folate. It doesn't, I think, actively transport homocysteine, but this might be some other reason which we haven't still investigated. And I can see Dr. Sadhana Joshi is also listening. She is just now doing many placental transporter studies just now. And we are collaborating with her to find out the regulators of these transporters in the placenta. Then we followed these children at 2 years, and what do we find? At 2 years, maternal B12 concentration in pregnancy is still a positive influence on the baby's B12 concentrations. And not only at 12 years, even at 18 years, we find that child's B12 concentration is still significantly related to maternal concentrations in pregnancy. Quite remarkable. That means transfer of B12 to baby during pregnancy is an important factor which determines the B12 stores of the baby. Second thing is child's cow's milk consumption is a positive determinant of B12 concentrations. On the other hand, you will remember these mothers were themselves quite B12 deficient. So prolonged breastfeeding from these B12 deficient mothers was a risk factor for B12 deficiency. That means the beta is inverse here, while it was positive for these two factors. So very interesting findings that maternal transfer to the baby is a good source of B12 for baby. Cow's milk, good source. But if mother is deficient, prolonged breastfeeding is a risk factor. Another interesting finding we found was that children who grew rapidly and put on weight are more likely to be B12 deficient, either because B12 is consumed during growth by the tissues, or there might be some other reason which we don't know, whether the, let's say, distribution of B12 in different transport proteins is different with this. But rapid growth, putting on more weight, risk factor for B12 deficiency. And this is the multivariate analysis. It shows that with increasing age, B12 goes down. Genes are related with positive score, so that remains with you. Maternal B12 and paternal B12 were additional determinants of child's B12. Weight was an inverse association, so rapid growth. Higher triceps, inverse, that means adiposity. But if the child was taller, its B12 status was good, so lean mass was positively related to B12 status. Milk consumption score, positive. Non-veg food consumption, positive. And total leukocyte count, that means white blood cell count on hemogram, was a direct association of B12, probably because the higher total leukocyte count suggested a degree of unhygienic conditions. So this is a model we have developed, which is called a life course model of B12 deficiency. We looked at another cohort we have in our department, IAEA B12, found similar findings. So what it says is genetics from father, epigenetics possibly from mother, but also probably from father, intrauterine transfer, lactational transfer, and then a whole lot of social, economic, religious, cultural, political factors in later life determine your B12 status. And this is not difficult to imagine. Those of you who are interested, I have contributed to this review on B12 deficiency in Nature Primer in 2017. Please read it. It's worth reading. And then nowadays we are interested about microbiome, because we know that B12 can be synthesized only by microbes, and therefore somehow or other the microbes which are living either in our intestine or on our skin or in different places might be either providing or consuming our B12 and therefore affecting our B12 status. And this is a part of our active research just now. I don't know much about it because these results are not yet available. Then I told you B12 deficiency is very common. It's predominantly a nutritional deficiency. and therefore we don't really need to give too large doses. So as Dr. Madan told you, we have started a pre-conceptional B12 supplementation trial in adolescents in the PMNS. The trial was recently completed. We are analyzing the results. But the girls who were severely B12 deficient could not be included in the trial because of a placebo control. So you can't treat severely deficient people with placebo, and therefore we excluded these girls from the trial but treated all of them. That is an ethics requirement. And what do we find? Giving them only 2 micrograms per day for 11 months increased their B12 status, reduced their homocysteine concentrations, and improved their nerve function, which we measured by different machines which we have. So we measured what is called pseudoscan measurements. We did nerve conduction velocities and showed that only 2 micrograms per day in these severely deficient B12 girls improved their nerve function, though the original values were all reported as normal by the laboratory, by the neurophysiology laboratory. So this is a very interesting thing, which is worth remembering. You don't need to really zap them with very large doses, but consistent long-term treatment is important. Best would be, of course, dietary source, if not fortified foods. And the last thing we would think of is supplements, because normal people usually don't take supplements for a long time. So we'll come back to the basics now. Yeah, I have shown you an intergenerational cycle of a nutrient, which not only has conventional actions like you would ascribe to a nutrient, but unconventional actions like regulating epigenetics. And therefore, I'm going to tell you that pregnancy is an experience for the two. There is a tremendous fight amongst the dietitians because they are mostly treating obese women. That pregnant woman doesn't need to eat about 2 micronutrients. She definitely needs to eat for the 2. So important to remember that mother is the vehicle to improve the nutritional status of the baby. Next, I'm going to say pregnancy is not only important for 2 generations, it might be important for 3 generations. And how come? This is a very interesting picture from David Barker's last published paper in May 2013. He passed away in August 2013. This is a paper in Nature. First author is his daughter, Mary Barker. And they show here a mother pregnant with a female child. And I don't know how many of you know, but all the ova in the ovary of this female child are present by 20 weeks of gestation. So from 20 weeks of gestation, you are dealing with 3 generations. You are interacting with the grandmother. You are supplying food for the daughter. Not only that, you are also influencing grandchildren. And therefore, this is one of the most dramatic figures you can see. Many times I gave talks in different meetings, and the last international meeting I spoke. After that, they used to ask questions to the audience, which was the most important slide for you in the talk. And thumpingly, this was the most important slide for many of the participants, and I'm sure it is for you also. Now I'm going to do a bit of advertisement. Okay, last month, we inaugurated this film, which we have done based on our research. This was directed by Srimati Sumitra Bhave and produced by Dr. Mohan Agashe. It is called Sakre Peksha God. And it is a film to highlight the importance of nutrition for a pregnant mother. And I think you should all watch it, and you should go on YouTube, go to KEM Hospital Pune, and that is the link on the YouTube. And this is one of the scenes from the film. It's a beautifully done film, and you should all watch it just to learn how an effective artist, which is Sumitra Devi Bhave and Mohan Agashe, can deliver a scientific fact very effectively. And I think this film is now going to become quite popular. So finally, I'm going to stop by thanking a whole lot of people who have actually influenced these studies. So these are collaborators from India and abroad, including David Barker, Caroline Fall, Shobha Rao here, many others. These are my staff members, and that is the administrator of the unit. This administrator openly blamed me for having only a 95% follow. So you can imagine it can be only my wife. So that's Pallavi. Then these are the participants when they were young, and now they are what? There are 700 of them, but these are taken at some meetings. And these are my field staff who have made all this study possible by close interaction with the participants and contributing to this substantial follow-up. So I'm going to stop here, just put up the slide that funding has come from many international and national bodies, and without that, it wouldn't have been possible. Thank you very much.
Thank you so much, sir. Indeed, a very, very, very interesting, informative, insightful, and a very comprehensive presentation. Certainly, this evidence based information should not lie only in the presentation. I think it should be translated by the practicing dietitians also. And
Ruby, can you
the
speak up a little, please?
Hello, can you hear me now?
Yes.
Yeah. I hope you heard the previous words.
No,
Yeah,
please
go on.
repeat.
Okay, I was just saying that it was interesting, very informative, and a very insightful and comprehensive presentation. Certainly, this evidence based information should not lie in the presentations of the researchers, but must be translated by the dietitians who are attending the session. And I think all the dietitians will agree that women are no different in terms of micronutrient intake and consumption, whether they are urban or rural, whether they're obese or underweight. So I think all these, especially during this portion ma where we are talking about 1,000 days, the translation of this information should be a part of the prenatal counseling for all the dietitians, because they understand, okay, vitamin B12 deficiency or take green leafy vegetables. But if we emphasize to the young woman who is going to be a mother that it is she is responsible for the three generations and the adult life of a child and a grandchild, I think they'll be taking more seriously. And they will educate their girl child to eat more nutritious food right from the time she's a teenager. And I think most of the dietitians will agree, but they also have a lot of questions which they may have, because while they're practicing, uh, is there excess? What about gut microbiota, etc., etc.? I think we need to answer some of the questions, and I see a lot of questions in the question answer box. So going further, I think I will, invite Ms. Shilpa Joshi to take the question answer sessions. We all know about her, but for the members of HADSA, you are attending the session for the first time. She is the Vice President of Indian Dietetic Association. She is a practicing dietitian, a director of a center called Mumbai Diet and Health Center. She is also the Honorable Secretary of All India Association of Advancing Research in Obesity. She's a master trainer of the Diabetes Conversation Maps, and she's very well known as the course director of NDEP program, who has trained more than 3,000 diabetes educators. We see her at speaking at different forums, whether national or international. We also know that she's a recipient of the Mimpheimer Guggenheim International Essay Award. It's my proud privilege to request Ms. Shilpa Joshi to join us and ask Dr. Professor Yagnik. And I think nobody better than her can do this job very well. I request Shilpa Joshi ma'am to unmute herself and shoot the questions which are there in the question answer box. Over to you, Shilpa ma'am.
Can you hear me?
Yes, ma'am.
Yes.
Am I audible? Yeah.
Yeah.
Thank you, sir. It was a fabulous, fabulous talk. And every time I hear you, we learn something different. I learn something different. Now, there are many, many questions which are put up. But before I, uh, uh, you know, ask you the questions which are put up, I wanted to ask you one question because I am moderating, I get the advantage of asking what is in my mind first. We see an increased prevalence of PCOS nowadays. Also, also obesity and a lot of infertility. And a lot of these women are given metformin periconceptually or preconceptually to regularize their cycles. A lot of them are also given oral contraceptive pills. And we all know they interact with B12 and lot of so is there any kind of correlation that we see especially in women with with PCOS and then getting pregnant, infertility and then getting pregnant, and B12 deficiencies, because you have extensively done work, even your subgroup Priya, have you seen anything like this?
Yeah, that's certainly true. What happens is that most of the PCOS girls visit many doctors, either because of menstrual problems, hirsutism, or due to obesity. So by the time I see them, they have all been treated. And as you said, commonest treatment is metformin, but usually they have received supplements. And therefore, it's difficult to diagnose their original deficiencies at that time. What I suspect is that PCOS may originate in B12 deficiency, folate excess imbalance, which I mentioned. Because if you see, all the risk factors are very common. But the number of PCOS girls in our cohort are so small that actually we are not able to pinpoint it. For that, we will have to set up a new study, prospective follow-up, especially like say girls born to PCOS mothers, so that we have more chances of seeing the outcomes. So I think that remains as an open question. It's possible, but from the dietitian's viewpoint, it will be important to balance their micronutrient intake, either by balancing their food, which would be the best way of doing it, taking fortified foods as an additional thing, or finally providing supplements, because in modern days we find that as the most easy way of actually overcoming the deficiencies. So yes, that is a high risk situation, and we must make sure that we supply them with all the micronutrients. And what I told you says that do not give folic acid alone without supplementing B12, but that might have unintended sort of outcomes in the baby.
Sir, there is a question, and I'm taking questions. So, question from Dina Cheda. She has asked that so which supplement needs to be given, especially since strict Jains do not even consume dark green leafy vegetables for 4 months in the monsoon. So, do they need to be be more cautious about supplementing?
Definitely yes. Now, when they are really semi-starving, as if during these 4 months, we should provide them adequate micronutrients and also macronutrients. And as I said, given the modern life requirements, if we give a multivitamin tablet which has a balanced micronutrient content, then it should be enough. And for me, usually I use simple tablets like Bacosols, for example, and that covers most of the things. We might have to need sort of give vitamin D separately because majority of our population are D deficient. So in addition to telling them to sit in the sun in the morning or late morning, you also provide oral vitamin D. How much good it does, no one really knows. But it's practice to improve the circulating levels and hope for the best.
So there is a question, and this question was also in my mind, which I wanted to ask you. In adults, when should the vitamin B12 supplementation be considered, which you have answered? Which form is recommended? So we also see increasingly people not giving tablets, but giving injections. So whether oral injections or how do you recommend?
Okay, so B12 can now be given orally, either in low dose or high dose. You can inject it intramuscularly. There is also a nasal spray, and there is a sublingual form. Now, the forms which are available are cyanocobalamin, which is the common old B12 form, which has been used for a long time. Last 10-15 years, methylcobalamin has come on the market. That's predominantly a Japanese product and was originally on the market for treatment of diabetic neuropathy. And it is almost always given in very high doses, starting with 500, 1000 or 1500 micrograms. Now, if you give orally, given the regulatory pathway which I showed in the slide, you can absorb only 2 to 3 micrograms through that pathway. If you give more than 5 micrograms, only 1% of the additional B12 is absorbed by diffusion, not through the active pathway, but by diffusion. So if you give, let us say 100 micrograms, 1% would mean 1 microgram. So very small amount. Now there is difference between people, no doubt about that. But only small amount is absorbed and large amount of it is excreted. If you give a 500 microgram B12 injection, 85 to 90% of it comes out in the urine within next 24 hours. So injection is given only when oral intake is not possible, or if you have an absorption defect like pernicious anemia, or a gastrointestinal surgery, or ileal tuberculosis, or Crohn's disease. So conditions which affect intestinal absorption. But nowadays it's possible to give either sublingual, which bypasses the gastrointestinal tract, or a nasal spray and avoid injection. And the doses for a nutrient deficiency because of dietary deficiency, if you give small doses, then it should be enough. Unfortunately, the lowest concentration of B12 in the tablet is 15 micrograms. That is either Bicosuls or Neurobion 4. So that should be more than enough for day's course of B12. If someone is severely deficient and symptomatic, you might give large dose for 4 to 6 weeks, saturate their body sources, and then you give low dose as a regular supply.
Another question, sir. Folate and B12 both should be given preconceptually. That's what we are understanding. So for what is the dosage of B12 and for how long preconceptually? I mean, when should you start supplementing a young girl with B12? At what point?
So if we go by our national programs, the national programs start, like say there is an ICDS program for children in the school. We could actually give it to them, and that would be the most effective way of improving the nutrition of the population for the long-term effect. That of course is a policy decision, and we are just now struggling with this. Then there is an adolescent program where we give IFA tablets. So IFA tablets contain iron and folic acid. And today, the dose of IFA tablet in the national program is only 1 per week. So you can't add B12 there unless you give very large dose, and that would not be feasible. So again, I am now trying to argue with the government that we should supplement B12 to school children and to adolescents and to pre-pregnant mothers and to pregnant mothers as a life course thing with small doses like 2 to 3 micrograms daily for a very long time. That long duration is very important. Otherwise, if you give very large doses, then after 4 to 6 months, again, you will come back to the original state because large part of that large dose is wasted.
Another question, is prolonged consumption, does prolonged consumption of vitamin B12 show adverse effect on health?
Not that I know of, though there are some reports of adverse effects in postmenopausal women, like increased fracture frequency. Very large doses of B12 have sometimes been associated in some populations with increased mortality in old people, sometimes with cancer risk. And same thing has been said about folic acid. So it seems that as people become older and older, 1-carbon metabolism disturbances affect various processes, and we have very little information. But as a general statement, I would say, if B12 is given in reasonable doses, there are no known side effects.
The question was, they would like to understand what is the influence of gut microbiota on B12 status?
Yeah, this is a very interesting question. And I have to say that I only know it has effect, but I don't know what, because that's what we are studying. There are many studies in the world, in the Western population, which are predominantly non-vegetarian. And non-vegetarian microbiota is very different than vegetarian microbiota. So we can't extrapolate everything from them. But what they found was that B12 deficiency was more associated with overgrowth of bacteria which consume B12 but cannot synthesize B12. So they are sort of obligate dependents on the B12. So they compete with the host and remove the B12 from their nutrition and consume it themselves. And therefore host suffers a relative deficiency. Whether there is a deficiency of B12 producing bacteria in the B12 deficient people remains to be proved. And then we know that various antibiotic treatments, etc., which affect the gut microbiota can affect your B12 and folate status. So this certainly needs more research. If there are any volunteers, please report.
Okay. Sir, one very interesting question, and that you said, I mean, we all know, and you also reiterated the fact that RDA for folic acid is about 400 micrograms, and that for B12 is 2.5 micrograms. Do we actually get tablets exactly to the point of RDA for supplementation, or we have to sort of restrict to what is available, as in folic acid 5 milligrams, and the lowest dose of B12 we get is 15 micrograms.
Yeah,
we have
very
to
good. So yes, we have to just now today restrict to that, because government has also now put out rules not to produce low dose multivitamin combinations for whatever reasons they have. Like in diabetes, they have stopped producing multi-drug combinations. Similarly, there is a problem about producing low dose multivitamin combinations. So we are stuck with what we have got. And the tablets which are under the category of multivitamin usually have up to 15 micrograms of B12, though I think there is one tablet which is 5 micrograms. I just forget the name. And the folate dose or folic acid dose in these tablets is 1 to 1.5 milligrams. So if you give that 1 tablet per day, I think that's more than enough. Giving folate is not essential except when a woman is pregnant after a previous pregnancy with neural tube defect. So to prevent a recurrence of neural tube defect, the dose of folic acid is 4 milligrams. So you can give a 5 milligram tablet. But for prevention of first occurrence neural tube defect, the dose is 400 micrograms. So you should not give more than 1. In Europe, there is something which is called upper safe limit, USL. And for folic acid, it is given as 1 milligram. For B12, there is no upper safe limit.
So there is also a question where they are asking, is there a correlation between hypothyroidism and vitamin B12 deficiency, and vitamin B12 deficiency and Alzheimer's, both?
Yes, the answer to both is yes, because hypothyroidism, as we know, is an autoimmune condition. B12 deficiency can also be an autoimmune condition, like pernicious anemia. Though it may not be full-blown pernicious anemia, thyroid women might have antibodies to intrinsic factor. So there is definitely an association. As a diabetologist, we see it in type 1 diabetes patients, where type 1 diabetes itself is an autoimmune condition. Then they might have thyroid problems, and then they might have additionally B12 deficiency. And second was there an Alzheimer's? Yes. There's a lot of active research just now going on the role of B12 in Alzheimer's. Just now we know there is an association. We don't know whether it is causal, and therefore there are various theories about it. If you have a particular genetic predisposition, that might be made worse by B12 deficiency. And there is something which I never spoke about today because it's a bit complex subject. Okay, there are B12 analogs which are called pseudocobalamins. So they are similar to B12 in part of its structure, but some parts of the structure are different, and they might interfere with B12 absorption or action. And there is a suspicion that some of the neurological conditions might be associated with pseudocobalamins circulating in the blood. Though this is still very much research, so you can't really quote me on this.
Again, there is a very interesting question that we understand that the presence of micronutrients is usually depleted in the source because of soil conditions and environment itself. First of all, is this statement true? And do you think then the supplementation is only way forward to meet the requirements?
Yeah, okay. So given today's sort of world with a lot of environmental pollutants, soil which is sprayed with insecticides and the other rodenticides, etc., can damage all the micronutrients. That is absolutely true. If cobalt is damaged, then vitamin B is cobalamin. So it's possible that we might have less B12 coming from the soil bacteria. So is supplementation the only way? So I think you told me last time you also had a talk on kitchen gardens and that kind of thing.
Yes.
So supplementation is not the only source, though it is the easiest way of doing it. It has its downside that people who are otherwise feeling normal don't take supplements for a long time. Therefore, we have to increase the intake from the natural foods. And what is the problem about B12? If vegetarians are not going to take non-vegetarian food. Now, which is the source of non-vegetarian food which is acceptable to vegetarians? So that is milk. So unless you are a vegan. So milk is non-vegetarian and it's a very good source of B12. So that could provide you B12 of good quality. There are also some algae, and we are just now testing chlorella for its effect in improving the B12 status. Very soon we will publish our paper, and then we are going to try and do bigger trials to see whether chlorella fortified food items are able to improve the population's B12 status. At one time, there was also that other algae, spirulina. Though currently there is a controversy that spirulina might contain large number of pseudocobalamins. So that is being investigated. Then there is a Japanese algae, marine algae called nori. So if you go to a sushi shop, they wrap their dumplings in the nori. That is one of the richest source of B12. So we should really innovatively include these items in your prescription so that people's B12 status improves from natural intake of B12 over and above the supplements which you are giving.
Sir, there is a question that in others, I mean, not just women, but in even in men, can B12 be supplemented without, I mean, when there are no symptoms of B12 deficiency, even then can B12 be blanketly supplemented?
Yeah, so there are two things. Okay, commonest symptom of B12 deficiency is no symptom. Most of the people are asymptomatic. And there are many vague complaints which in retrospect we say could have been due to B12 deficiency, because they will say burning in my feet, aches and pains, memory problems have all improved. So these are non-specific. So first statement was commonest symptom is no symptom. Second is large number of symptoms are non-specific. And therefore, and third statement is that in Pune at least, when I investigated B12 levels in the urban Pune, we found 80% of middle class Pune people had B12 deficiency. 50% of those in the slums have B12 deficiency, and 50% of rural people had B12 deficiency. So this is a huge burden. Therefore, instead of wasting time and money in measuring B12, I would say we would improve B12 status of everyone by either supplementation or improving the intake of B12.
Okay. This is again, sir, a very interesting question which says that Indians are inherently deficient in many micronutrients like iron, B12, folate, vitamin A, vitamin D, iodine. Do we really need to revisit the benchmarks to diagnose deficiency in Indian population?
Very good question. So I think we should in some ways to see whether we have adapted to these low levels, and therefore we should reset our thresholds. And that's just now the active research which I am doing with international collaborators to see whether there is any evidence of adaptation. Because if we are adapted, then zapping them with large doses of B12 might produce problems. So very clever question. Today, we don't know the answer, but at least for B12, I am trying to solve it. For other vitamins, we will need similar sort of high quality research.
There's another question, sir, that we know that excess folic acid in absence of B12 is cause of obesity. Is vice versa true? If B12 is supplemented, would it have elevated B12 levels would have problems?
Not as far as we know. So, yeah, honest, and unless you give very high doses, it's not very easy to produce large dose of B12, large concentrations of B12, because the B12 absorption, as I told you, is very closely regulated. Then you have to really zap that person with very large doses or give injections or give sublingual or nasal without any regulation, then the levels might go high. And large amount of B12 is excreted in the urine very rapidly within 1 to 2 days of supplementing.
Just one or two questions more. Can B12 supplementation during pregnancy help to improve the effect related to diabetes and obesity caused due to deficiency during peri and pre-pregnancy state?
Sorry, I just lost a little bit. Can you say that
Okay.
again?
So the question is, can B12 supplementation during pregnancy help to improve effects related to diabetes and obesity caused due to deficiency during peri and pre-pregnancy? Yeah.
Yeah, so I think the best way to supplement is preconceptional. If you are not able to do it, start as soon as possible. Whether it will prevent B12, our PRIA trial will tell us very soon in next 5 years, because the children will have grown and we will know whether their insulin secretion and resistance have improved after supplementing the mothers. So I can't tell you today that it will, but my hope is that it will, and let us all hope that it will. So that's what I have spent last 7 years doing, PRIA trial.
Okay. So you were speaking about autoimmune disease. There is a question, can Takayasu, which is an autoimmune disease, post-delivery be managed and improved with an improved level of vitamin B12?
Okay, Takayasu is actually a immune aortoarthritis. It's relatively rare. As far as I know, there is no indication that B12 deficiency is responsible for that. But I just don't know because it's such a rare condition. I haven't seen any cases.
And what is the relation between vitamin D and alkaline phosphatase enzyme and effect on bone, liver, and kidney?
So vitamin D.
Yes.
Yeah. So when vitamin D is low and rickets occurs in young growing bones, you get high alkaline phosphatase, yes. And that is from the bone. So you have to do the bone specific measurement or do other measurements to show it is coming from bone. In adults, vitamin D deficiency usually wouldn't give you high alkaline phosphatase unless it's very severe and there is some recovery of bone after a fracture or something like that. So alkaline phosphatase is not used as a marker of vitamin D deficiency in adults. What we use instead of that is PTH, parathyroid hormone. So if vitamin D levels are very low, then we see whether physiologically body is perceiving it as low or bones are perceiving it as low and asking for more. And that is operated through the parathyroid hormone. So elevated PTH is a good marker of functional vitamin D deficiency.
So there's a question also that can vitamin B12 deficiency inherited from mother ever be totally reversed, leaving no chances of occurrence of diabetes or obesity?
Yeah. See, what we are talking about is nutritional deficiencies, but 10 to 15% of our B12 levels are determined by our genetics. So what you inherit are all these SNPs. It's called polygenic inheritance. You can't do anything about polygenic. Now, there are extremely rare forms of genetic disorders, which of course come from parents, or sometimes de novo, which block transport of B12 within the cells. And they have very peculiar manifestations in neonate or in infancy. And there the treatment is, of course, to give adequate B12 in different forms. And once you have inherited it, all you can do it is to give B12 in appropriate doses over lifetime. They are very rare. I mean, I haven't diagnosed any as yet, but I know world authorities who have many cases in their sort of reports, but they are very specialized investigations. We can't do it in India.
Uh, uh, One last question. Could micronutrient supplementation initiated at menarche among girls take care of pre-pregnancy as well as post-pregnancy nutrition status among deficient population?
Okay, I mean, menarche might be delayed due to severe undernutrition. But nowadays, the new problem we are facing is, especially in the cities, the overweight, obese girls are getting premature menses.
Correct.
And there is a large prevalence of PCO in that population. So with all attendant problems. So micronutrient deficiency and menarche are related in the sense that severe micronutrient deficiency might delay it, as was the case in severely undernourished children when we were young, because that time the nutrition status was very poor in India. Now that kind of thing can happen only in remote places.
There are more questions coming up. Do we have time, Ruby? Can I ask sir couple of more, or the time is up?
We can have one more minute, then it will be 18:45.
Yes.
Okay.
I have another call at 7:30 for which I have to prepare.
We can excuse.
So,
So, sir, can one question be asked, or?
yes,
Okay.
ask one last question.
Okay. So will B12 absorption be upregulated in severely deficient people?
Excellent question. So we have done B12 absorption studies, and I had omitted that slide from the presentation because I didn't want to complicate it. And that compared the absorption in Indians with Europeans. So remember, our B12 levels are very low. So absorption of B12 is much more vigorous in deficient people than in sufficient people. So that is true. Very nice question. And therefore, as a group, deficient Indians will absorb much more vigorously than the sufficient Europeans. So we had to reset our test, and whosoever asked question, if you want to see that, it's paper sometime in 2009-10, you can write to me and I can refer you to that paper.
So thank you so much, sir, for being so patient and answering so many questions. Thanks a lot for a wonderful presentation as always. Thank you so much.
Thank you. And I would request everyone, and I would request IDA, please circulate the YouTube sort of link which I have given. If you have a website, put our film there. It's directly related to what we discussed today. It's not about B12, it's about general nutrition, and the dietitians would learn quite a lot from that interesting film. And I would invite you to actually show it in your clinics when young girls and pregnant women are coming to your clinic. So you can put it out in the anteroom.
Thank you, sir. Thank you.
Thank you, sir. We will definitely take that up. It can benefit a lot of people. So we would love to do that. I personally want to thank you once again for giving a wonderful talk and answering most of the questions. And Shilpa ma'am, as always, you've done a wonderful job of moderating this Q&A sessions. We will definitely continue this trend of question and answers. Most of the panelists are today attending a session who will come back to us on the 28th, which is Monday after at 5 o'clock. We will continue this discussion at a length once again. I can see Dr. Prema ma'am, I can see Dr. Sadhna Joshi with us, Safal Mahadik, Roshan, Dr. Ganesh, who are already there listening to sir, and probably take this discussion further and make it a very interesting uh, panel discussion on 28th. I request everybody to come back with the same Zoom link which has been circulated to rejoin the program on Monday evening. Meanwhile, sir, this program will be incomplete without a formal vote of thanks. And to invite the representatives from IDA Mumbai chapter and HATSA, I request my co-host, who is the co-convener and the committee member of IDA Mumbai chapter, Ms. Megha Terse. Megha, I request you to invite the people who will give the vote of thanks to sir and all the delegates here. Once again, I want to thank you, Dr. Professor Yagnik, for this wonderful session.
Thank
Over to
you
you,
once
Megha.
again. I'm sitting in dark. I'm just going to switch the light on here.
Okay, sure, sir. Your talk was any which was very enlightening, more lighter than ever before. It has brightened us. Over to you, Megha, please.
Thank you, ma'am. Sir, it was really an insightful talk, and we are really
Okay.
privileged to have you here today. So without any ado, I call Jayshree Paranske ma'am, who is the co-convener of IDA Mumbai chapter, to give away the formal vote of thanks.
Thank you, Megha. At the outset, I would like to say thank you very much, Dr. Yajnik, for such a wonderful talk. And it was a topic which is very dear to us, and we learned a lot. And we assure you that Mumbai chapter will definitely take up your suggestion of putting up that video on our website. Having said that, B12 deficiency, B12 folate, all these micronutrient deficiencies, what havoc they can create. You have made it, you have simplified it in your talk. Once again, thank you so much from IDA Mumbai chapter. My thank you will not be complete without thanking our national president, Dr. Chakmeet Madan ma'am, who has always encouraged us to conduct such sessions. Thank you, ma'am. Thank you for attending this session. I would also like to thank the HADSA representatives who are there today with us, but I will not, I mean, it will be wrong on my part if I don't mention Dr. Smata, with whom the association began with HADSA. It was Dr. Smata who Dr. Smata and IDA Mumbai chapter began this association, and I assure you that we will go a long way. All the panelists who are present there today to attend this session, all the senior members, all the senior faculty members, and if I have forgotten to mention everyone, we are very, very thankful to all of you to attend it, a successful webinar. I would also request all the members to keep visiting IDA Mumbai chapter Facebook and the YouTube channel, because all the recordings of these sessions are available. Recently, we have been conducting number of programs, and you can revisit these programs and be updated. Ruby, you are the convener of this program, Ruby and Megha. You have done a wonderful job, and hope to see you on 28th with the panel discussion. Thank you so much. And thank you, Dr. Vaibhav, for, being, for associating with IDA Mumbai chapter. And it is our joint venture. And we assure you that we will have many such programs in future. Thank you. Over to you, Megha.
Thank you so much, ma'am. I call upon Mr. Kaushik Desai, who is Secretary General from HADSA, who's having more than 30 years of experience in pharmaceutical industry, to give away the formal vote of thanks.
Okay, thank you, Megha. Yeah, it's my privilege actually. I got the same sentiments what Jayshree has already said, but nevertheless, from HADSA, I like to thank Professor Yajnik. We appreciate your spontaneity in accepting our invitation to deliver keynote address on the main theme, and you set the ball rolling. We are thankful to you, sir, for sharing very insightful presentation and highlighting mainly the importance of vitamin B12 and the folate in a much simplified way with case studies. And your expertise was evident from the question answer session. Dr. Jagmeet Madam, you have been always inspirational to IDA and extremely supportive of good cause. Thank you, Madam, for your presidential address and active participation. I must thank our HADSA Secretary and Board Member, Dr. Vaibhav Kulkarni, in initiating and supporting this webinar series with IDA Mumbai chapter. My sincere thanks to Shilpa Joshi, Vice President, National Vice President for IDA, for very efficiently and effectively conducting question and answer session. And of course to IDA Mumbai chapter leadership team, Ruby Sound, Jayshree, Megha, Nitya Desai, and many more, ably led by Chairperson Zamrud Patel. Thank you very much. And I'll be failing in my duty if I do not acknowledge my secretariat, Dipesh, duly guided by Lina Amanna, for hard work and the coordination for this webinar and the subsequent webinar what we'll have on Monday too. Finally, thanks are due to all the participants for making this webinar much interactive with your participation and making this event a success. We once again look forward to see you all, maybe with more of your networking professionals on Monday, 20th September, for very exciting panel discussion. Thank you, one and all.
Hello.
Thank you once again, everybody.
Yeah, Ruby, just a second, if you don't
yes,
mind.
Yes, ma'am.
Yeah, during my vote of thanks, I forgot to mention my very dear friend Shilpa Joshi, who has conducted the session so wonderfully. And so I must take this opportunity, Shilpa. Thank you so much
Thank you, ma'am.
for being here. It is just that you are part of us, so it was just a slip of tongue. So thank you so much, and we will keep connecting with you and getting back to you.
Yeah. All thanks to our chapter convener Zamrud ma'am for taking this forward, connecting the dots and making it a big success. Once again, thank you all from the convener and the co-convener of the chapter and the convener co-convener of the program. A very good evening to everybody and look forward to see you on Monday. Have a great evening, stay safe, and see you on Monday. Bye everybody.
Bye.
Thank you so much.
Okay, bye.
Bye sir.
Thank
Bye.
you, sir.
Bye-bye.
Thank you.
Keep in touch.
Definitely, sir. You
Thank
will
you,
definitely
sir.
see the movie on our
Bye-bye.
YouTube channel. We will
Yeah,
play it for everybody.
right.
We will connect back soon. Bye.